Hi, welcome to Physics Teacher. This is part 2 of a force problems tutorials for beginners meant for grade 11 physics students. If you haven't seen part 1, make sure you go watch that first. And in part 2, we're going to add the force of gravity, so stay tuned. Alright, so here are the steps that we used and learned in part 1 of the videos, except I've added another one. So let's go through these steps to solve this problem, and we'll see what step 4 is for this one. So here we have a dolphin experiences a force of 320 newtons up when it jumps out of the water. The acceleration of the dolphin is 2.6 meters per second squared up, and we need to calculate the dolphin's mass. So step 1, we draw a free body diagram. Alright, so in this case, we have a force up. We can just call that an applied force. Let's say FA is 320 newtons. Now we're always going to have a force of gravity, which is going to act down. So this is FG. And again, on any free body diagram, I just like to write to the side the direction of acceleration, and then also choose a coordinate system where our positive direction is in the same direction as acceleration. So I'm going to make up positive. Step 2, write F net. So what is F net? In this case, acceleration is vertical, so we care about our vertical components. Our applied force is up, so it's going to be positive. So let's write FA. And then FG is down. According to our coordinate system, it is going to be negative. So minus FG. Alright, so that's step 2 complete. Step 3, set F net equals to ma. So F net I will write as mass times acceleration. And that's going to be positive because I'm choosing the positive direction to be the same direction as acceleration. Now step 4 is going to replace the force of gravity with the equation mass times our gravitational field strength, where the gravitational field strength has a magnitude of 9.81 newtons per kilogram on the surface of the Earth. Now it's very important that you don't make this negative. It is true that acceleration due to gravity is down, and I chose up to be positive, but this coordinate system is to show the direction of my force vectors in this equation. So I choose up to be positive because it's the same direction as acceleration, so I know that F net will be positive. That's why ma is a positive value. I chose applied force as being positive, and I chose gravity as being negative. So I've already brought that negative directional component outside of this vector. What's left here now is just the magnitude. So we're just going to sub in positive values to solve for that magnitude. So the applied force is 320 newtons minus mg. So there is step 4. Our next step, finally, is to solve. So we're solving for mass again. So I know the acceleration is 2.6 meters per second squared. And that's going to equal 320 newtons minus the mass times 9.8 newtons per kilogram. So I have mass here and mass here. So let's collect like terms. I'm going to bring this whole term to the other side of the equation. So we're going to have mass times 2.6 meters per second squared plus mass times 9.8. And if you like, you can change the units of newtons per kilogram to meters per second squared. They're equivalent. You don't have to, but it makes it easier to see that we're going to add those in a minute. And that equals 320 newtons. So now we can factor out a mass, where we're left with 2.6 meters per second squared plus 9.8 meters per second squared is equal to 320 newtons. 2.6 plus 9.8 is just 12.4 meters per second squared. And that equals 320 newtons. And if we divide both sides by 12.4, we'll get the mass to be 320 newtons divided by 12.4 meters per second squared, which is 25.8 kilograms. I hope this tutorial helped, and stay tuned for the next tutorial where I'm going to add the equations for frictional forces.